separate namespace. You can have them share namespaces. They can share the same namespace with the local environment. So that's why there's no identifier in the kernel saying we're in container number 1, number 2, number 3, etc. Because what is a container? You could be half in one container, half in another. It's kind of a fuzzy concept. So because of that, we have several different options for identifying which environment we're in. The one that we picked, that I picked for this, was using the root directory, the object for the root directory of the current PID, specifically the D entry and the VFS amount. We looked at the pointers. So in effect, that means that this becomes the sysname lists we're talking about are not even per container. It's not Docker specific or anything. It's just per root. So anything that has an alternative root that's different from the global environment, you can get a different sysname list for. A benefit of this is that this concept it's not only not Docker specific, it's not Linux specific. It extends to all other platforms. Everybody, anything Unix-based typically has an idea of a root, a root, a jail, other things. Anything that has a different root directory. And since we're a file system, that seems like that made a lot of sense to me. Different root file systems may be different. You may have different platforms installed in there. Even if it's not through a container, you could have a root that has a Red Hat installation, and you could root into it. One other class, so I've only implemented this for Linux right now. We have heard of, there is some interest from at least one site that was interested in getting this on Solaris and using it for their zones, their Solaris zones. If we did that, I don't know if we make it per zone or just make it per root like we did here. Solaris does have the kernel concept of a zone. It's a discrete object that the kernel is aware of, so we could do it that way, but a true root is probably more consistent. So just to give a look at what that looks like, the code for this adds a few new options to the fs sysname command. The first one up there is assigning the container in PID 1234 to sysname AMD64 at FS7. If you don't specify the PID option, either to get or set the sysname, will give you the sysname for the current, like the current context. It will give you the sysname that we would actually use to expand at sys. So that seems consistent for backwards compatibility. It's the same thing that you would like. If you run fs sysname, you expect it to give you the list that will actually use to expand at sys and paths. So this still retains that. But to set it or get it for a specific other PID, you specify the PID option. And if you want to get the global one that's shared by processes that don't have a specific PID, a PID-specific sysname list, and you specify the -global option. We have a -delete to get rid of the per container at sys list, so that processes in that container would then default back to the global one. And we have this -debug PID name sysnames to look at the list of sysname lists that's currently active. And since so I mentioned we're doing this with PIDs, so you just have to give a PID for anything in that container, anything that uses that root or alternative root. So if you have a Docker container ID, some kind of reference to the Docker container, this is just an example of a command that can be used to get a PID in that container. That specifically gets the top level PID, the thing that Docker waits for to exit. You can specify any PID inside the environment, and it will still work. Setting sysnames still requires root access, specifically capsysadmin. Docker containers typically are run unprivileged, so you don't have that. You don't have the rights to do that, even if it makes it look like you're root, but you can't actually do any privileged operations. So I just mentioned that because I make some references to setting the PID inside the current container, inside the current root. For Docker anyway, you really wouldn't be doing that. The intention is that you would be running these commands from the global environment to set up the sysname list for a container, presumably right after you start it or during initialization, something like that.
So that's capsysadmin in the global namespace, not
yes. The PIDs I think are also resolved in the global namespace, but like I said, usually you don't even run in Docker container, so it doesn't matter. So here's some examples of actually running those commands, what the output looks like. So it's basically the same as our current the current way the command looks, it just adds a few things. So you set the sysname list for a PID instead of setting the sysname list. It should all be it's all pretty similar to what exists right now. That's the that's an example output from that that new option that gives you the list of the existing ones. We record both the original PID that was given to the command when you created that alternate sysname list, and the last PID to reference it. So we clean these up automatically every 5 minutes or 10 minutes or something like that. We look through the whole list we have in the kernel, and if there aren't any PIDs that are possible to reference that, then we get rid of it. So that means if there's anything referencing it, then it'll stick around, and if you want to see why it's sticking around, those PIDs are helpful. Maybe you forgot what the first one was, or that first doesn't exist anymore. We keep track of what the last one was if you need to try to track down why it's still there. And the key is just those are our raw pointers to the entry and BFS mount. Different platforms, maybe on different platforms, this key, it would be anything else. On Linux, maybe our implementation will change in the future, and the key would be something else. So I just consider that, it's an arbitrary object. And in that example, I just do x86 and z64. So this is, it's implemented, it's submitted in Garrett. We have a couple sites that are running it in a testing capacity just to kind of evaluate it. Or I guess we have one site that's testing it, that's running it in a testing capacity. The other sites we are waiting for hearing back from the team that requested it. unless you have news from me.
We were going to go production with it.
Okay.
Oh. That's good news.
I'm not aware of any issues with it, but I just haven't heard back anything from.
Oh, yeah, we've been testing it for a couple of weeks, and it's a huge win. I know we did Quest originally, but it's a huge win for us just because we have, just the ability to run containers of different OS releases and kernels. It's just huge consolidation.
Okay, well, good. So specifically, I was looking for feedback from the teams that had experience with this because I don't know much about Docker, so I don't know if the interface is convenient or annoying or something like that. So if it's working, that's good. Okay, yes. So we have a site that's going to production very soon, apparently. And of course, we'd like to get it in an OpenAFS release. It is in Garrett. I don't think the code's not too complicated. The main thing is just refactoring things to accept the idea of different sysname lists. So there are some areas that they have to look up a thing. There's some mocking added. So it's not trivial certainly. So I don't know when we'll see that in a stable release, but sometime, hopefully. As I mentioned, we also would maybe be looking at porting it to Solaris at some point in the future. The interface should be able to be exactly the same, and of course, any other platform, if anybody wants to use this for something else, it can probably be done. The last thing there, a Docker plugin. So this is the thing. So I was alluding to this. I don't really know much about Docker. The places that requested this of us, usually the people we're talking to, also don't know a lot about Docker. They're kind of requesting it on behalf of another team that runs all the containers. So I wasn't quite sure what the best practices. This is like an extra AFS command you have to run. There is some idea of Docker plugins. I took a brief look at it. I didn't see anything that looked quite like this. All we need to do is run that one privileged command. So it might be more convenient to specify some metadata inside the config instead of having to run a separate command, and then the plugin would run it for you. But that's not necessary. Maybe that's just not worth the effort looking at. Right now it works, and it seems pretty simple. So code is in Garrett there. Slides are the usual place. Oh yeah. So any comments? Any questions? Yes, go.
So when you executed this fs system command, so it was executed on the host or inside the container?
On the host.
On the host. And that on the host we need that sysadmin privileges.
Yes. Cap sysadmin is just, that's the existing privilege check for setting sysnames. So I just kept the existing one. It probably doesn't need to be that restricted. It's probably possible to do something else that's a little more relaxed, but it's never been a question. It's never even come up in conversation before. So I don't know what the ramifications are of maybe doing that.
just curious to know means I know that ideally we run.
Oh, sorry. Hold on a second. Yadav was asking about the privileges of changing the system. We have to run those in the host environment, the host namespace, and it does require capsysadmin in the host namespace. Yeah. Sorry, go ahead.
So typically we run a single process in a container, but sometimes I have seen that we start a process and that process spawns multiple processes which might have a separate PIDs. And it could happen that child process is doing some builds. So how we will get the list then for the system?
How would what? Sorry?
We will get that list because in the list, but whenever we check in the list, we check with the PID.
No. So the Yadav was asking about in the containers. Usually they run one PID for the whole container, but it may spawn it may spawn children. So how do we do that if we're checking PID? So the PID that you specify is just that's when you set the sysname list, we look at the PID and look at what its root directory is, and the root directory is the thing that we store, and we like for future checks that's what we check. So as long as those children have the same root directory, they don't root or something like that, then that should work. And then that interface too, I wasn't sure about at first because that can be like counterintuitive, like you just demonstrated. I just wasn't sure of another way to like specifying the path to the root wouldn't work because you have to have the right VFS mount and deentry. So like specifying a string, I don't know I don't even know how to get that from Docker. What the specific path is that you look up, and it may not be. And I don't think it's even possible to do that in the host environment because it's not just the directory at this path, it's in a different mount namespace. So I don't think in the host you can access the VFS mount. So that's why we go directly from the PID. And when we need to do the lookup, the only information we really have is the current process. That's the context that we have. So that's why it's very analogous. So however we would do, so even if we changed it from not using the root directory, it's whatever, like this PID, however you would do the sysname lookups, make it so this PID would use this list. And presumably that would be true for the children as well. Okay, thank you. That's it. Okay.